Good morning, students. Jai Swaminarayan. Today I am going to upload a lecture because the topic under consideration is very simple and you will enjoy it, students. So, today we are going to start exercise 3.3, and that concept, students, is geometric mean. Geometric mean, students, one of the easiest concept, and I suppose it is very interesting. Now, students, today we are going to start the topic of geometric mean. Now, students, let us understand this definition with the help of an example. Students will study the definition with the help of an example, and that will, you can say, easily help you to understand the concept, students, behind the geometric mean. Trust me, it is very simple, and students, it is very easy. Now, I have given two numbers. Suppose, students, I have 2 and 8. Mind you, for geometric mean, we should always consider positive real numbers. Suppose I have two real numbers, 2 and 8, then their geometric mean will be the product of two numbers and its square root. So, geometric mean will be square root of 16, and all of you know that square root of 16 is 4. Suppose I have three real numbers, 2, 8 and 4. Then its product and cube root, 2 into 8 into 4, will give us geometric mean. So, geometric mean will be cube root of 64, and again that is 4. So, in short, if I want to find geometric mean of two numbers, I multiply and take square root. If I want to find geometric mean of three numbers, I multiply, students, and take cube root. So, if I want to find geometric mean of four numbers, I multiply and take fourth root. So, in general, what is the definition of geometric mean? Suppose the positive numbers given are A1, A2, A3 up to AN. Students, pay attention. This definition is given on page number 82. So, all of you please concentrate. Suppose we are given positive numbers A1, A2, A3 up to AN. So, we are given n numbers. So, the nth root of product of A1, A2, A3 up to A is defined as geometric mean of this n numbers, which is denoted by, students, capital G. So, the definition of geometric mean goes like this, students. Write the fact. Suppose the positive given numbers are A1, A2, A3 up to AN. Nth root of product of A1, A2, A3 up to AN is defined as the geometric mean of, students, given n numbers, and geometric mean is denoted by the symbol capital G. So, in short, technically, suppose we want to find geometric mean of two numbers, then you take the product of two numbers and take square root. Suppose you want to find geometric mean of three numbers, you multiply all three numbers and take cube root. You want to find geometric mean of nine numbers, you multiply all nine numbers and take 9. In general, if I am given positive real numbers A1, A2, A3 up to AN, students, the nth root of the product of A1 to AN is defined as the geometric mean of given n positive numbers. The symbol for geometric mean is, students, capital G. Now students, all of you pay attention. Students, arithmetic mean and geometric mean, a relation between two. A relation between arithmetic mean A means x bar and geometric mean means capital G. Students, I want to cite a very important relation, a very important, you can say, equation between arithmetic mean and, students, geometric mean. Let us continue in the same example. Suppose I am given two numbers. Suppose the given two numbers are 2 and 8. Arithmetic mean is x bar is equal to 2 plus 8 divided by 2. So 10 divided by 2. So how much? 5. All of you know that if I want to find the mean of two numbers, suppose I want to find mean of two numbers, then how would I do, students? Add two numbers divided by 2. And geometric mean already we have found out the square root of 2 into 8, and that is root of 16, that is 4. You can check x bar is greater than G. Then suppose we are given the three numbers which I am taking as 2, 4 and 8. X bar will be 2 plus 4, 6 plus 8, 14 divided by 3. So it will be, students, 3 4s are 12 and recurring, so 4.67, and geometric mean is cube root of 64, which we got as 4. Again, x bar is greater than G. So, as such, arithmetic mean, simple mean, students, is always greater than geometric mean. What interpretation, students, we have here? Simple mean, arithmetic mean, students, is always greater than geometric mean. Arithmetic mean and geometric mean are equal if and only if both the numbers are equal. Suppose I am writing here. This is an example. Suppose my observations are 5 and 5. Now arithmetic mean is 10 divided by 2. So 5. Geometric mean is square root of 5 into 5, which is 25. So 5. So in this case, x bar is equal to G. This, the result is very important, students, for all competitive examination. Always arithmetic mean greater than geometric mean, and they can be equal provided all the observations are equal. What result, students? You have to memorize. Once again, students, arithmetic mean x bar is always greater than geometric mean, and arithmetic mean and geometric mean are equal if and only if all observations are equal. This you note down. I am again reiterating the result so that students, you can note down your fair go. A very important result. The result goes for distinct observations x1, x2, x3 up to xn. Arithmetic mean x bar always greater than geometric mean G. If all the observations of given data are equal, then and only then arithmetic mean x bar and geometric mean G are equal. This result, students, you have to memorize. And again, a very important concept which is given in B-Merit, geometric mean is not defined when observation is negative. If one observation is 0, you can say all the product of observations becomes 0. So we have to be very careful. Generally, geometric mean is not defined when observation is negative or 0. Because if one of the observation is 0, the product of all observations will stand to be 0. And any root of 0 is 0. So it has no meaning, I should say. It has no meaning. Geometric meaning has no meaning when one of the observation is negative or 0. This is also a very, very important result, students. Now, we are doing, students, exercise 3.3. It has 3 sums. The following data shows the number of books read by 8 students of a class during last month. Find the average number of books read using geometric mean. Here we are told to find average number of books which are read, students, using the concept of geometric mean. So, first of all, let us start with the first sum. Students, exercise 3.3, sum number 1. Given ungrouped data observations, excite, which I am noting down, students, 1, 2, 1, 5, 2, 1, 5, 9, 1, 3, 2, and 4. So number of observations are 8. Now, students, what does the definition says? How the definition goes? Recall, if there are 2 observations, multiply, take square. If there are 5 observations, multiply all 5, take fifth root. So if there are 8 observations, multiply and take which root? 8th root. Because this number of observations given are 8. So, according to definition, G is equal to, I should write, according to definition, G is equal to 8 root of product of 2 into 1 into 5 into 9 into 1 into 3 into 2 into 4. So this becomes 8 root of the product of all this turns out to be, students, 2160. Now, students, 8th root means you have to take 3 times square. 8th root means you have to take, I am writing here, take 3 times square root in simple calculator. And your answer will turn out to be 2.61 books. 2.61 books. So, students, we can easily find 8th root using your simple calculator. 3 times, students, you have to take square. First find square root of 2160. Whatever answer you get, again find square. Whatever answer you get, again find square root. 3 times square root in simple calculator will give you, students, the 8th root. Okay, students, now we are doing sum number 2. The value of a machine depreciates at the rate of 10%, 7%, 5%, and 2% in its first 4 years respectively. Find the average rate of depreciation using an appropriate method. Students, all of you concentrate. Students, here depreciation is such a topic which is unknown to you at present. Students, sum number 2 is regarding depreciation. I shouldn't write this present. Pay attention. I think Sachin sir would have depreciation. Okay, Sachin sir would have taught you what is depreciation. I think you asked Sachin sir in accounts. Let me explain. Say you buy a new car for 10 lakhs rupees today. Now after 1 year, the market value of the car won't be 10 lakhs rupees. It would be 8 lakhs rupees. So your depreciation is 2 lakhs rupees. Like that. In the second year it is 8 lakh. In the third year it becomes 7 lakhs. So it goes on depreciating. That is called depreciation. So you buy a new cell phone today at the rate of 50,000 rupees. Even if you sell it after 3 months, you will get 45,000 only. So that 5,000 is your depreciation. So depreciation is a topic which will be taught to you students in detail in accounts. Sachin sir will help you to deal with depreciation. So students, you need not worry at present. So what is the sum? Depreciation of the value of a machine depreciates at the rate of 10%. So in first year, at the end of first year, its value is only 90%. At the end of second year, whatever value is there, again it depreciates by 7%. So you can say the value is 93% of what remains. Students, check example number 15 is similarly done. So for depreciation, students, we have to consider the given observations xi. First observation x1, depreciated value is 10%. So whatever value is there, 100 minus 10, it becomes 90%. Then again in the second year, 100 minus 7. So whatever value was there, of that 93%. Again in the third year, whatever value is there, 100 minus 5. So it is 95%. And in the fourth year, it is 100 minus 2. So 98% of what value exists. So whatever value was there, that we suppose as 100%. So this is, you can say 90, this is 93, this is 95, this is 98. Mind you, whatever value, suppose I told you the mobile you bought was of 50,000 rupees. That is 100%. Now it is depreciated by 5,000. So in the next year the value becomes 45. That becomes 100% for depreciation for the third year. Like that it is, students. So if I want to find, students, the rate of depreciation, then geometric mean according to definition, geometric mean will be fourth root of product of 90, 93, 95 and 98. And that is nothing but fourth root of the multiplication of all these terms out to be 7792 4700 7792 4700. To find fourth root, take 2 times square root. Takes 2 times square root in your simple calculator. So this gives us students 93.95%. Correct. Now this is all, this all value is 100 minus. So you can say average. I am writing here. Final answer will be G is equal to 100 minus 93.95%, and that is nothing but 6.05%. So the average rate of depreciation is 6.05%. So this is the geometric mean. Whenever it is percentage increase or percentage decrease, depreciation is percentage decrease, and appreciation is percentage increase. So for depreciation we have to subtract from 100. For appreciation we add to 100. This much students you remember and mark this sum as one of the most important sum. Now students, we are doing the third sum of exercise 3.3 students. Now we are doing the third sum of exercise 3.3. Students, pay attention. Second sum we mark as very important. Now students, the third sum reads as follows. A taxi traveled 15 km on Monday and 254 km on Tuesday. Find the average distance traveled over these 2 days using geometric mean. So a taxi, it travels only 15 km on first day, Monday, but it travels 250 km on Tuesday. So these are ungroup data observations. So we write given ungroup data observations xi are 15 and 254. So according to definition, if I want to find geometric mean of two observations, what I will do? According to definition, geometric mean is square root of 15 into 254. So this multiplication turns out to be 3810. And you can find square root of this, and square root of this turns out to be 61.725. So we can round it off to 61.73. Done. So the geometric mean, if you go for arithmetic mean, it will be very large. It will be, you can say 269 divided by 2. Now 270 divided by 2 is 135, so this will be 134.5. Arithmetic mean is always greater than geometric mean. Students, very important result in CA, in CS, in MBA, all competitive exam. This is one of the most important result, that arithmetic mean is always greater than geometric mean, and arithmetic mean and geometric mean are equal if and only if all the observations of the given data are equal. So this completes our exercise 3.3. This concept of geometric mean is very important, students, for competitive exam students. So this concept of geometric mean is very important, students, for competitive exam. As such, we have 5 types of mean defined. I will note down for your understanding. First is arithmetic mean, simple x bar. Second is geometric mean, which we have studied, denoted by capital G. Third is the harmonic mean, which is denoted by H. This will be taught to you in your MSc Statistics. Fourth is combined mean, denoted as x bar C. And fifth is weighted mean, denoted by x bar W. So remember this, for our statistical, you can say inference, we have 5 type of means. First is arithmetic mean, which is denoted by x bar. Second is geometric mean, which is denoted by capital G. Third is harmonic mean, which is beyond the scope of your book. It is studied in 11th 12th science. Fourth is combined mean, which we have already studied. Fifth is weighted mean, which we have already studied. Okay, fine students. Now I am taking all the concepts of you can say geometric mean from exercise 3 also, section A. MCQ 4. Section A, MCQ 4. Section A, MCQ 4. Just now I have told the result. For any sets of observation, which of the following results is true? Arithmetic mean is always greater than geometric mean. It is equal to when all the observations are equal. So according to the option, correct option is C. So this is the answer. Remember, very important result, students, for all competitive examination. I repeat, we have done also arithmetic mean always greater than geometric mean. In one condition, arithmetic mean and geometric mean are equal, when all the observation students are equal. Next is MCQ 10. What is geometric mean of observations 4 and 9? We are given two observations. Geometric mean will be square root of their product. 4 into 9, square root of 36 is 6. Square root of 36 is how much? 6. So, the correct option is, students, option B. So, option B is the correct answer. Option B, students, is the correct answer. Okay, further, now students, section B. Now, students, we are doing section B. In section B, I don't think we have any question related to geometric mean. No, students, I don't think we have any question related to geometric mean. Okay, section C, students. All of you pay attention. Yes, section C, we are given some number 8. Section C, students, we are given some number 8. That question is also related to, students, geometric mean. Okay, what is the question? Geometric mean of two numbers is 8. Okay, capital G is given as 8. Fine. Given numbers are say x1 and x2. Out of two numbers, one number is 4. Then find the other number. So according to definition, G is equal to square root of 4 into x2, and that is given as 8. Yes or no? According to definition, if we have to find geometric mean of two numbers, we have to multiply and take square root. Now to remove square root, squaring both the sides. To remove square root, we do squaring both sides. Here square root will be removed and 8 square will be 64. So x2 will be 64 divided by 4, and that is 60. 16 into 4 is 64. Its square is 8. So this is the answer. So this is very important concept, students. Geometric mean is a very important concept, and it is widely used, students, in all competitive examination. It is, students, widely used in all competitive examination. Now, students, here after that, section D, sum number 7. Section D, students. Now we are doing section D, sum number 7. Okay, students, now all of you pay attention. Section D, sum number 7. I think practically this is the last sum of geometric mean. The economic growth rates of a state for 4 consecutive years, growth rate are 2%, 2.5%, 3% and 4% respectively. Find the average growth rate using an appropriate average. So here, whenever you are told an appropriate average, the best possible mean is geometric mean. Growth rate is always increase, so it is 100 plus. So let us note down the given ungrouped data observations. Section D, sum number 7. The given ungrouped data observations x1, x2, x3 and x4. x1 is 100 plus 2, sorry, growth rate is always in terms of increase. Then 100 plus 2.5 is 102.5. Then 100 plus 3 is 103 and 100 plus 4 is 104. Okay, students, now we have to multiply all this. So, according to definition of geometric mean, G will be 4th root of product of 102, 102.5, 103 and 104. So this is 4th root of, the multiplication of this is a very big number, 1199. 1199. Then it is, students, 3960. 3960, a very big number. 1 crore 19 lakhs 93,960. Take 2 times square root in simple calculator. So this gives us 102.87.